Saturday, June 8th. It's about 8:15. Sun's back behind the mountains. Got a few high thin clouds. You can see jet leaving a vapor trail. A bit long if you ask me, but they're not patterned in the sky, so it's probably just a pure vapor trail. Besides, it dissipates towards the end. We have high thin clouds, but the clouds are thinner and more dispersed than they were earlier. I'd like to point out that Canyon Mountain, which I'm going to zoom in on in a second here, if you can see it, no longer has any snow at the peak. So that's it. By Midsummer's Day, it is all gone, even though the mountain's 9,000 feet high. Already got the scope set up. I did a brief synchronization and realignment slightly to Arcturus, Cornicoros, and Vega. And I'm planning, the plan for tonight is to try to capture galaxies further north, to the north and the east before they culminate. They'll be high enough in the sky to get good views, but I generally can't pick up galaxies near culmination more than 45 degrees north. So I'm going to go through a list here on the handset and make a list of galaxies, for instance NGC 6702 and other studies. This one's in Lyra. It's brightish, magnitude 12.2, 1.9 by 1.5 arc minutes, elliptical class 3, which are relatively devoid of any kind of texture, 221 million light years distant. But the key idea is that at plus 45, 42, 21, I'm going to look for galaxies that are above 45 degrees in declination off to the northeast and other studies, and see how high I can go. I'm hoping I actually can track down one or two that are actually in Draco. We shall see. Before we start off in the evening's adventures, which are going to detail NGC studies and others that are as far north as I can get when I poke the scope towards the north and the east, I thought we'd have a look at this rather obscure study. What we got right now is we have this little annularity in the screen. It's a planetary nebula, and I've got it set on the 3-inch scope settings. Let's pump it up, or down in that case. So now we've basically gone from 4 flood to 8 flood, which adds about 0.8 magnitudes in terms of reach. So we've gone to like a 4.5-inch scope. And there's our view of this featured study right now to begin the evening. If we go to 16, we now have what I would consider to be a 6-inch scope view. With each step, of course, in flood rating, the exposure time goes up. At this setting here, it shouldn't take more than 4, maybe 6 to 8 seconds to fully compile an image. Now we'll skip up to here, 32. It's about a 9-inch scope's view. At some point, we might even be able to make out the central star, which is about magnitude 14.5. I do believe I'm seeing some faint apparition of it. We're heading towards 128 flood. But you know, I was thinking tonight I may go full max of these galaxies that we're going to be looking at, just as an experiment. What do you think? All right. So now we go to 64, just like a 12-inch view. And I've been told that under really good conditions, you can see the central star. If you're at high altitudes, you see stars to magnitude 6 in the night sky in the region of Lyra. You should be able to make out the central star. As I said, it's magnitude 14.5, but look at all the luminosity it's surrounded by. So that makes it a little harder to pick it out. Nice stellar region, up to 128, and now we're probably going to start gathering too much light, which means we're going to lose the texture in the image, and we're going to push it to 256 flood. And we've completely lost all texture. We just have a blob of light. And I have one more step I can make to 44.8. We are approximating now about 1 magnitude deeper, probably something in the region of a 36-inch scope. None of the resolution, none of the beauty of the background sky, none of the pointillistic tendencies of stars, but in terms of light gathering, we've maxed out this Revolution 2 system on a 6-inch scope. We're pushing 5 to 5.5 times the aperture, somewhere between 30 and 36 inches of aperture. We have a 15 by 20 arc minute field of view at roughly 75x. And let's go ahead and explore some more northern galaxies with these settings. We are in color mode, as you can see. We have a bright background sky despite the fact that we've now entered into sky dark. I saved the settings. We're completely overwhelmed. But let's go ahead and have another adventitious look. How about another planetary nebula? And you should be able to identify what it is. It'll also be a Messier. You see where it ends up on the screen. I noticed today in viewing the video I published from last night on a large screen that pushing the image forward like I have using the zoom function has actually gave a decent view in a large screen. So I'm going to play with that tonight, although when I resume the NGC series, I'll have to go back to 128 flood, 42 decibels, and I will not be zooming in on the screen for consistency. But here is our look at Messier 27, the dumbbell. Now also notice it's going to take quite a while to make those 6 passes. Each pass is about 5 seconds. That would ordinarily be 30 seconds. But if there's any shifting around of the image, it has to recompile. So oftentimes it can take over a minute to generate a fully stabilized image at these settings. That is a very nice look at the dumbbell. So let's go on to another one. Take a look at it as well. Another midsummer favorite, because we are looking away from culmination to the east. Okay, here we have another favorite of summers past. This is NGC 6888, otherwise known as the Crescent Nebula. Let's give it a little bit to form. I'll tell you a little bit about it. 6888's a nebula, emissive, well, it may be a reflective nebula. It's not saying here. No, it says emissive. Nebula in Cygnus, magnitude 10, 20 by 10 arc minutes, emissive type, 4,800 light years distant, but we are at right ascension 20 hour, 12 minutes, 6 seconds, but we're only at declination 38, 21, 17. The goal for tonight is to push the declination. I'm hoping we might actually pick up a galaxy or two in Draco. I'm not sure if we will because of the roof tri to the north and the east. But I figure if I capture it early enough, we might get a decent view. So there's our view of the Crescent Nebula, 6888. Once again, it may not be a fully developed image on the screen. I am not giving the full minutes at this point that it takes to compile the image. But there's a pretty decent view. All right, the scope just pointed towards NGC 6702. I'm going to run a little test here and see how long it takes the image to develop. You can see streaking from past stars associated with 6888. Those should first disappear, and then we should start compiling an image of a galaxy, and I'll tell you more about that galaxy in a second. It is an interesting fact that you have to do 2 strokes to enter any study on the handset. The first to align to it and the second to go back to it to get the data after it aligns. NGC 6702 is a galaxy in Lyra, the Lyre. Its magnitude is 12.2, 1.9 by 1.5 arc minutes. It is an elliptical class 3, which means it should be kind of a fat Bob star up there. 221 million light years distant puts it probably at about 125,000 light years in diameter. Fairly large for an elliptical galaxy. Its right ascension is 18 hours, 46 and 57 seconds, but its declination is 45 minutes, 42 and 21. And I do not believe we are getting any obstruction at this point, so I should be able to go further north. Although, I cannot tell you if we're making out that galaxy. Shifting around on the floor is causing some streaking. So let me go ahead and sit still for a few seconds as I look up our next galaxy. And the next galaxy is brighter and larger. It's also an lenticular class, which should be a little more interesting. Sorry if I'm going to bail on this before we get a good view. But it does appear, if there's a galaxy at all, it's distinctive in that magnitude. It's way near the top of the screen, which does concern me from the point of view of centering. But I have noticed there has been some deviation in the coordinates of various studies. So I have to be careful about repositioning and resynchronizing the model. Until a pattern really becomes apparent, we don't prefer to do that. So I'm going to shift to 6703 at this next point. As it turned out, NGC 6703 was only a few clicks away, another galaxy in Lyra. Magnitude 11.3, 2.7 by 2.5 arc minutes. Lenticular spiral, 103 million light years distant. Puts this one at about 100,000 light years in diameter. We're at right ascension 1847.18, declination plus 45.33.02, and I would say we have at least another 2 or 3 degrees north that we can go from here. That screen is looking pretty good, and I can see something that's definitely galactic up on that screen, although it's in an entirely different location. We'll have to play with that tomorrow when I put the video together. Go ahead and allow that one to develop as I look up our next study, which will be 6711. So I'm just going to skip along until I get to 6711 on the handset. And there we go. Now we're going to be going to 47.5 degrees north. Let's see if we can pick something up without obstruction of the scope. Okay, what we're hoping to see now unobstructed, and it looks pretty close to being unobstructed, is NGC 6711, a galaxy in Draco. This may be the very first galaxy I've actually turned up in Draco. Its magnitude 12.9, smallish, 1.3 by 1.2 arc minutes. Spiral with a bar. It's a lowercase bc, so that means it's 2.5 times removed from a lenticular to the right on the Hubble Divaculaires morphological chart, and it has peculiarities. The galaxy is 213 million light years distant, so it's probably about 65,000 light years in diameter. We're at RA 1849.0 and declination 47, 39, 27. And I am seeing a rather nice little galaxy over there. Unfortunately, it's not very well centered on the screen. We'll have to look for a pattern tomorrow. I'm going to look up our next study, which is 6732, navigate to it on the handset, and allow that image to continue to formulate. Another galaxy in Draco, but at 52 degrees this time. Let's see if we can make it out. Here we'd be looking for NGC 6732, a galaxy in Draco. Faintish, magnitude 14.5, but well within the reach of the scope on a decent night, especially at the maximum settings I can input into the Rev2 CCD imaging system. 1.2 by 0.7 arc minute elliptical, so it's pretty ablate for an elliptical. 362 million light years distant, puts it at about 110,000 light years in diameter. We're at 18 hours, 56:24 seconds, declination plus 52, 22, 38, and I will look for our next study, which is going to be NGC 6742. So I'll allow that one to continue to develop. Now remember, this evening I'm basically seeking out studies in the 45 to 55 degrees of declination, north declination, to see what we can pick up that are further to the east. Here we have NGC 6742. I'll turn off the camera as we navigate. NGC 6742. You're not looking for a galaxy here, even though it's in Draco. This should be a planetary nebula, smallish, certainly smaller than the ring we saw earlier. It's faint too, magnitude 13.4, 31 by 30 arc seconds, with a central star of magnitude 19.4. At these settings, I wouldn't expect to see a star fainter than magnitude 18.5. However, this is a very distant planetary, 20,400 light years distant. So in terms of relative size to the Ring Nebula, this was about 8 times further out. So it would probably be twice the size of the Ring if we were at the same distance. We're at right ascension 1859.19 and declination 48.27.55. I think we have the full aperture on the scope, but excuse me, we are getting close. You can see the planetary right there. So yeah, things are shifted off into that left-hand corner. We should be looking at that position. Everything's turning up, so I probably will not resynchronize at this point. As long as we have a consistent notion of where things should turn up, it should work out pretty well. Well, we've clearly found our limit now. NGC 6750, Galaxy in Draco, is at 59 degrees, 9 minutes and 59 seconds. So we're not going to get anything in this. We're getting highly obstructed. I don't think we're getting any light at all. Are we seeing any stars? No, only artifacts. So no, we can't go as far as 59. However, it's possible that if I had been able to catch everything about an hour earlier, so tomorrow night if I reproduce this experiment, what I will do is shoot for something in the 7000 series so we can be looking further east. And we should be able to get up to 60 degrees in terms of north declination. So I'm going to limit it now to about 55. This was 59, so 6750. Our next study is 6757. We'll see what that looks like. 55 degrees north, so let's go ahead and have a look at this and see if we can pick anything up. Okay, we're at NGC 6757 plus 55 degrees and 43 minutes. We're getting about half the aperture of the scope. Obstructed, you can see a star up there, maybe faint glimmerings of a galaxy. That galaxy in Draco 6757 is magnitude 12.9, 1.4 by 1 arc minute, spiral with a bar of the lenticular class A, so 1/2 removed from pure lenticular, and it would have a bar. It also has a ring, 113 million light years distant, so probably about 50,000 light years in diameter. We're at 1905.06, declination 55:43.03. I am going to go ahead and just forget the rest of my list and jump to 7,000 and see just adventitiously whether we could pull up some galaxies up to 60 degrees north if we move ahead by about an hour in right ascension, which is about 15 degrees. I do believe we're seeing somewhat of a faint galaxy right about there, but we are getting obstructed at 55 degrees north declination. However, this galaxy is in Draco, which is nice. All right, we've shifted to NGC 7000. As I recall, that is the North American Nebula in northern Cygnus. I'll give you some data on it, even though I doubt we'll make it out. It's a very large emissive type nebulosity. And I'll also be able to determine its declination. It looks like we got plenty of clearance.
Once again, we're going to shoot for something in the 50 to 60. Oh, NGC 7000 Nebula Cygnus, magnitude 4, 120 by 30 arc-minute emissive type, 1800 light years distant. Right ascension now is almost 21 hours, 20:59:20, with a declination of plus 4413. I think we're going to shoot for studies that are in the 50 to 60 degree north declination range now that we've shifted further to the east. I do believe there's some faint nebulosity on the screen as well as the space bug, but I don't think the space bug is getting many bites out of it, even though it can leap many light years in a single bound. Okay, what we're seeing develop here, towards the middle of the screen in the top, I believe, is NGC 7008, a planetary nebula in Cygnus. Magnitude 12, fairly large, 86 by 69 arc seconds, with a central star of magnitude 13.9. The planetary is located 2,800 light years distant. We're at declination 54:32:34 and right ascension 21 hours and 32 seconds. Kind of hard for me to tell whether we're getting any obstruction, primarily because the bright light of the screen is affecting me, but I think we're getting a little bit of an obstruction on this one. So the plan to go to the 7000 series and push the limit to 60 degrees. I wish I could tell where the scope is pointing. We are getting obstructed. Is not going to work with the 7000 series, so I'm going to make another leap to 7200. But we are getting a nice view of that planetary nebulosity. Sweet. I can only reach the camera now. All right, we've gone too far. We're now getting blocked, not by the roof try as much as the roof of the house. I'll tell you about NGC 7226, and we're going to go back to the original list now because we're not getting any real gain on this. Not much in the way of aperture on this particular study. I believe it is NGC 7226. The open cluster in Cepheus, magnitude 9.6, small 1.8 arc minutes, 25 stars, the brightest of which are magnitude 10.8. It's a class 1-1, which means all the stars are pretty much the same magnitude and they're all pretty tightly compacted, 8,500 light years distant. We're at right ascension 22:10:26, declination 55:23, 54, and nope, we're not going to do any better than 55 degrees north declination. We should be seeing NGC 6764, another galaxy in Cygnus, magnitude 11.9, 2.2 by 1.2, oblately presented galaxy, spiral with a bar, lowercase b/c, 86 million light years distant, puts it at about 50,000 light years in diameter. We're at right ascension now. Remember, we progressed to the west, 19:08:16, and a declination of 50 degrees, 55 minutes and 58 seconds. I do believe we're getting, if not all, pretty close to all the aperture on this study. So let's allow it to develop as I step through to the next one. Ooh, it's a planetary nebula at 4627. Let's have a look at it. It looks like that trail to the top of the screen when I first pushed the button was a meteor passage. What we should be seeing is NGC 6766, planetary nebula in Cygnus. It's also NGC 6884. Magnitude 12.66 by 5 arc seconds, so unresolvable. With a central star of magnitude 16.7. This planetary nebula is 12,500 light years distant. Right ascension 20:10:23, declination 46:27:39. Our next study is, it's 83, so it's just before its alternative identity. So let me jump to 83 while that continues to develop. This will be a galaxy in Cygnus. Faintest one yet, a magnitude 15.5. Let's hope we get the whole aperture on it.
Well, folks, the handset locked up, and when this typically happens, I have to reboot everything. So, I had on my list probably 1, 2, 3, 4, 5, 6, 7 more studies, and well, we'll give it a shot. We've got plenty of bars left on the camera battery, so why don't we reboot? And that means I have to go and manually center the bubbles. Ooh, it's going to be a bit of a mechanical problem. It's definitely locked up. There's nothing to be done about it. Anyway, let's see you in maybe 10 minutes after I get a chance to straighten all this out. Well, I bet you had the same idea I had. After having to bail on that northern excursion and having determined pretty much that I am limited to about 55 degrees north declination, I decided, what the heck, I've got it set up for maximum luminosity. And what we're seeing here are those beautiful nebula in Sagittarius and Scutum, etc., etc. Wow. This is, of course, Messier 8, otherwise known as the Lagoon Nebula. Extremely brilliant, which explains why it flashed the other day when I was playing with settings, because we are gathering an exceeding amount of light right now at the highest possible sensitivity. But we're not getting quite the texture we might otherwise get. But it is brilliant. So let's tour Messier 8 with the Lagoon before we knock off and go on to Messier 16 and 17 and I believe it's 20. So we want to tour the Swan, we want to go to the Eagle, and we want to pick up the Trifid. So let's step through these, and I'll leave it up there as I'm going to my next study. And yes, I did have to do a bit of mechanical realignments. Once the Gemini stalls like that, you really have to just manually tell it to go somewhere like park. And then you have to position the park using the bubble levels on the different axes to get it to fit in, to settle down the way you want it. And then you have to reinitialize the park after you've got it all set up. So. All right, we're going to go on to Messier 16 here in a second, but that is an absolutely brilliant view of the Lagoon Nebula, Messier 8. That trail you're seeing on the screen was a satellite passage. You can usually tell how fast they're going based on, across the screen based on the screen size and the duration of each exposure. We're operating at slower times, so it made more progress across the screen than we ordinarily would get. For those of you who might venture a guess, we're now looking at Messier 16, the Eagle Nebula, which is an emissive nebula with some dark regions. Almost this part here almost looks like an eagle in flight, the dark nebulosity. But you can also conceive it as being an eagle that's flying. You're looking at it from below or above. So I'm not exactly sure what we're referring to when we talk about the eagle, but I do like this dark nebulosity. And it's got claws, there's the body, and the wings are outspread. So yeah, I could easily make an eagle out of that. Messier 16, nebula in Serpens, magnitude 6, 30 by 40 arc minutes, 7,000 light years distant, and we are a number of degrees below the celestial equator. So let's go pick up our next one before. Messier 17, of course, is also, I suspect that'll be the Swan. And of course, here we have the Swan, Messier 17, also called the Omega. Nebula in Sagittarius, magnitude 6.0, the size of the Moon, 30 by 30 arc minutes, 5,000 light years distant. We've imaged this before. It's also overpowering. Now you know why you have settings on the CCD imager. If you really want to do a good aesthetic job of capturing a particular study, you should play with the settings until you get the right amount of texture. We are seriously overexposed here, but we are seeing some nice texture there. And if it was like still astrophotography, you'd overlay the images You diminish the really bright parts, you'd enhance the fainter parts so you can get the most well coiffured image quality possible with the maximum amount of structure. And the best you can do in real-time imaging is just by setting the settings, focusing on what you want to reveal in the image. So there's Messier 17. I believe our last study is going to be Messier 20, which should be the Trifid Nebula. Of the nebulosities we've imaged thus far at the highest possible settings, we're probably getting the best view of the Trifid Nebula. You're seeing the zones of division. It almost looks like a running man, leg, body, and head. And the emissive nebulosity itself, you're seeing plenty of nebulosity around it. You're seeing some star formation in the cluster. This is probably the optimal setting for Messier 20, and that's maxing out the sensitivity and the exposure time of the image on the Revolution 2 system. Quite brilliant, but not necessarily the study I want to go out on. So let's think, where would we like to go? I just love the dumbbell, don't you? Let's have one last look at the dumbbell, Messier 27, before we... Okay, here we see another example of a really bright nebulosity that's being overexposed. Although we do bring it out, it does look like a dumbbell when you look along the 10 to 5 o'clock axis, but it should look more, and it does look more like a football when you look across the 2 to 7 o'clock axis. So as we entered into this series of studies by changing set points, let's take a look at this, the dumbbell nebula, which is a Messier class study like the last 3 or 4, and see what it looks like if we reselect our settings. So I go to Settings, Custom, Manual. All right, this is 256 blood, 44.8 decibels. Let's start by reducing the sensitivity. Now we can step through that. Okay, it's going to take too long though at 256. So let's just go to 42, which is the standard. All right, and let it reset itself. We'll go back up here. Allow the image to develop. Then we'll start, why not step down to begin with so it'll happen quicker. Let's start at that, I believe it was 4, which I called the 3-inch aperture equivalent. Let's see what it looks like there. So looking at the data at Messier 27 while it resets itself, should give me an idea of the average surface brightness. Messier 27, Planetary Nebula in Vulpecula, the Fox, magnitude 7.3, 8 by 5.6. You multiply 8 by, let's say, 6, you get 48. You take the log 2.5 of 48. That's about 4 magnitudes, I believe. You add that to the magnitude 7.3. Let's say this is probably got an average surface brightness of about magnitude 12. And a magnitude 12 average surface brightness study should give you a pretty good view in a 3-inch scope, although I am not seeing anything up there. But I am a long way from the screen, so I can't make any particular declarations. The image should have formed already. Why don't we step up to the 4.5-inch scope equivalent? That's 2, that's the wrong direction. All right, we go to 8. Let's see if we start to pick something up. Now, the dumbbell obviously was discovered in about a 3-inch, long focused 3-inch scope. Should be quite visible, easily seen as something that resembles a comet. I've seen it through a 3-inch scope under good conditions. It does give a dumbbell-esque shape. But I am not seeing anything up there, and it should have generated itself fairly quickly. once again, I'm not at a very good angle, so I can't make any declarations. So let's go to the 6-inch scope, which is most of my eyepiece experience has been through a 6-inch scope. And the dumbbell nebula is present on the screen. We are seeing some color, not bad. At this setting, it should take about 2/3 of a second times 6, 4 to 8 seconds to fully compile an image. I think we've given it that amount of time. Now we'll step it up. Whoops. We will go to the 9-inch settings and watch it develop. Yes. Oh yeah, very present at 32 flood, 42 decibels. Right there. In fact, that probably is the optimal view. We're seeing color. We should see the central star, which is about magnitude 14.5. Let's have a look at it at the 12-inch setting right there. 64 flood. Beautiful. Nice color, good texture, very artistic rendering, nice stars, black background field. And we're going to make one more leap to 128 flood, which is my standard for most image capture for just about all studies. I'm going to leave it there. We're going to navigate out, return, navigate out, return, navigate out, exit, and save. So this is going to be our Carpe Noctem view. So we're basically getting something that looks about like a 20-inch, 22-inch telescope. We're seeing the full extensions of not only the dumbbell, but the football-shaped annularity to the cluster, to the planetary. We're seeing the central star. We're seeing beautiful regions of texture and color variation, from red to green to lighter green with some blues thrown in. This is a very nice view of a spectacular Messier study, Messier 27, the Dumbbell Nebula. And with that, we will say Carpe Noctem.